So let's determine the interval or intervals on which f of x equals 3x minus ln of 2x is concave down. Well, the function is concave down. That means that our second derivative is going to be negative. So let's figure out what the second derivative is. If we have f of x equals 3x minus ln of 2x, then our first derivative is going to be the derivative of 3x, which is 3, minus the derivative of ln of 2x. Well, the derivative of ln of 2x is 1 over 2x times, because of the chain rule, 2. And that's going to be, cleaning it up a little bit, 3 minus 1 over x. Now let's write that as a power to make it easier to take our second derivative. We're going to write it as 3 minus x to the negative 1 power. Now taking our second derivative, well, the derivative of 3 is 0. The derivative of negative x to the negative first power is x to the negative second power, which is 1 over x squared. So we're looking for x's that are in the domain of our original function that make our second derivative negative. Well, the domain of our original function, since we have a natural log in it, and the natural log can only have positive inputs, the domain for our original function are x's greater than 0. So we're looking for x's greater than 0 that make our second derivative negative. But our second derivative is always going to be positive, right? Because it's 1 over x squared. And for any value of x, that will be positive. So there are no values of x that will make our second derivative negative. So what does that mean? Well, that means that our original function is never concave down, or concave down for no values of x.